Okay, in this video, we're going to look at how to solve log equations. So from what you did the other day, you probably already have a good idea of how to do logs, but this will give you some more challenging problems to try and things to think about. So the first couple here, remember if you have a log, the inverse of a log is an exponent. So it goes log is base, answer, power. The exponential form is base to the power is the answer. So I know base, answer, power. So I would say 2 to the 5th is x, so 32 is x. Okay, again, you can double check your answers. So if you put in log and base 2 of 32, you should get out 5. So it's a good habit just to mentally check or use your calculator. ln works the same way as a log, but remember when you do ln, it's the base here is e. Okay, so it'd be e to some power is an answer. So if you helps to write it in, but you'd have e to the 5th is x. Well, e to the 5th is about 148.4. Again, if you check it, you should get ln of 148.4 is about 5. Okay, I want to point out the next one. If you notice, there's no base written. And remember, when there's no base on a log, it's always assumed to be base 10. So again, if it helps, write the little 10 in there, but 10 is the base, -4 is the power, and x is the answer. So 10 to the -4, remember negative exponents flip your problem. Well, 10 to the 4th is 10,000. If you try it on your calculator, it's going to give you a weird one, e to the -4, which is scientific notation, which means you go 1, 2, 3, 4. Okay, so these answers are the same. Don't do this answer here. Don't leave it in 1 e to the -4. That's not appropriate. Okay, what about if they move x around? So you can move x in different spots. So I could do x squared equals 16. And to undo a square, I'd have to square root it. Again, test out your answers. If you try log and base 4 of 16, you get 2. But if you try the -4, it gives you a non-real answer. Okay, so the solution to this one is only the +4. The -4 would be considered extraneous. A little bit different looks, some more complicated questions. Again, just like with exponentials, we want to get the log part by itself. So that 3 and 5, I've got to start by moving those over. So I'd subtract the 3. And then I would divide by my 5. And then I can rewrite. So you've got to isolate that logarithm. So get that by itself, and then you can go and rewrite it into exponential form. So 2 to the 3rd is x, so 8 is x. If I put an 8 in for x, log and base 2 of 8 is 3. 3 times 5 is 15. 15 plus 3 is 18, so that's a good answer. So again, get in the habit of checking them. The next one here, again, I got to get this log part by itself, so I'm going to start by dividing by 2. And then I can rewrite it. So 3 to the 2nd, now it's equaling 5x minus 1. Well, that's 9. And if I add over this 1, I get 10. And divide by 2. Okay, again, if you want to substitute that 2 in there, 5 times 2 is 10, minus 1 is 9. So log and base 3 of 9 is 2, and 2 times 2 is 4, so that one works out. So again, either use your calculator or mental math to make sure that they're not coming out something that doesn't work. Again, ln is e, but I want to get that by itself, so I got to start by dividing by 5. And I can then rewrite e to the 8th. E to the 8th is probably a really big number that I don't know off the top of my head. So let's go 2980. See if we subtract that 7. And then we would have to divide by 3. Okay, again, you can go double check, substitute that one in. Obviously, that one's not going to be mental math, but substitute that in there and try it on your calculator. The answer should come out 40. Okay, next little type here. These ones are kind of nice because they have logs on both sides. I will never give you where these do not match. Those will always match. Even in college algebra, they're going to match. But, you know, if you have the same thing on both sides, they're going to undo each other. So I can start by dividing by the log of 4 on both sides, and that would cancel out. So I'm left with 5x minus 7 equals 3x plus 1. And then I can do some rearranging so x is 4. Double check. If you substitute in a 4 there, 20 minus 7 is 13. If I put in a 4 here, 3 times 4 plus 1 is also 13. So it's a good answer. Okay, same thing here with ln. I could start by dividing by ln on both sides and they would cancel out. Okay, so if I move over this 5x, I like to keep the x positive, subtract the 10. Okay, so let's check it out. 5 times negative 2 plus 8 is negative 2. 6 times negative 2 plus 10 is also negative 2. But the problem is our domain on our log has to be greater than 0, and so we can't ln a negative 2. So this would be an extraneous solution because we got an answer, it just doesn't work. It's a little different than when you get put it in the calculator and it says non-real answer to start with. So this would be considered extraneous. We got a solution, but it's not going to work with this problem. Okay, last little type I want to solve on logs is using your properties. So you learned this last week here that the plus on a log is, the property for that is going back to multiplication. So in this one, if I want to condense this log, I'm going to have to take x times x plus 4. Okay, and then I think I'm going to go ahead and distribute this out. So x squared plus 4x. And now I can rewrite it. So 2 to the 5th is equal to this. So 2 to the 5th is 32. Now this one's quadratic. So quadratics, you have some options. You could do square root method. You can do the trident or trinomial or backwards foiling. You could do quadratic formula. I think this one, since it looks like a trinomial, I'm going to go ahead and do factoring. So I can do plus 8 and minus 4. And if I solve those, I'm going to get x is negative 8 and x is 4. Keep in mind this one, I can't do a negative. That's extraneous. The 4 over here, those should work. And again, you can double check those by putting them in your calculator or doing some mental math there. So last one, this one has a subtraction. So if I'm subtracting, the property for that was division. So I'm going to write those as a division problem. And now that I got it kind of condensed into one log, I can rewrite it. So 3 to the 2nd is equal to x plus 5 over x plus 1. Let's see, that's 9. This is a rational type, so you can multiply by the LCD, you can cross multiply. I'm just going to go ahead and cross multiply this one. I'm going to go distribute the 9 that way and multiply by 1 this way. Again, if I move my x over, and then if I move that 9 over, and I would solve and get negative 1/2, okay? And I can double check, like I can stick in negative 1/2 of there because if I add 5, it's still positive. If I stick a negative and 1/2 in this one, again, it's still gonna come out a positive value. So we can double check that on our calculator, but that one would be a good solution even though it was a negative answer because we're not logging any negative numbers. Okay, so that's your rundown on how to solve log equations. We started with some easy ones and got up here to the complicated ones. So go ahead and finish your Google form. What's next this week?